All right, Brian, here's number 11. Sketch the graph of the following function. Complete parts A through H. Vertical asymptote. We have one at x equals 4. Horizontal asymptote. Notice that the degree of the numerator is greater than the degree of the denominator. So in that case, we do not have a horizontal asymptote. But because, if you notice that the degree of the numerator is 1 greater than the degree of the denominator, we do have a slant asymptote. So let's find it. You can either do this by long division or synthetic division. I'm going to do the synthetic division. We're dividing x squared minus, well, plus 0x minus 7 by x minus 4 to find the slant asymptote, okay? The quotient will be the equation of the slant asymptote. So if you put the coefficients, that will be 1, 0, and negative 7. Notice we're missing the linear term right there. There is 0x, so you still got to put the 0 in there. So bring down the 1, 4, 4, and then we don't care about the remainder. Okay, so the equation of the slant asymptote is going to be y equals 1x plus 4. For now, y equals 1x plus 4, and you graph that when we graph our f of x later, all the way in part H. But let's find the x-intercept. Well, these two can't go together. If you want to find the x-intercept, set y equals 0. Plug in y equals 0. And y is f of x. So say 0. Oopsie, sorry. Say 0 equals x squared minus 7 over x minus 4. Let's solve for x here. What can we do? We can divide, we can multiply both sides by x minus 4. If you do that, we get x squared minus 7 equals 0. And you know, the x-intercept happens on the zeros of the numerator. So you could have just set the numerator equal to 0 and say those are the x-intercepts. But let's solve this. X squared minus 7 equals 0. Add 7, you'll get x squared equals 7. Take square root of both sides. What happened? You get x is plus or minus square root of 7. Because you want to write them in an order pair format. First x-intercept is at square root of 7, 0. The other one is at negative square root of 7, 0. Okay? The y-intercept is when the x is equal to 0. So this time, set y equals 0 squared minus 7 over 0 minus 4. If you simplify this, you get negative 7 over negative 4. So that's going to be 7 over 4. So in order pair format, that's going to be 0, 7 over 4. So these are all these points that we can graph. They're not nicest looking points, but we can still plot them to graph in the function later. Now, from this point on is calculus, right? We're trying to find the interval where f is increasing and what interval is f is decreasing. We need to show all work. All right, so let's do the first derivative. Whenever you are looking for the increasing or decreasing interval, you need to find the first derivative. F of x is x squared minus 7 over x minus 4. Use the quotient rule, okay? Use the quotient rule to find the f prime of x. Remember, quotient rule is you're taking the derivative of a quotient. We're going to call the numerator f and the denominator g. The derivative will just be over g squared, gf prime minus fg prime. So let's label everything we know. F is x squared minus 7, then f prime is 2x. G is x minus 4, therefore g prime is simply 1. If we plug in all the pieces we have here, then we're going to get, the denominator will be x minus 4 squared, because that's g squared. And the numerator, let's do gf prime. Gf prime will be this times this, right? So let's write those two. fg, whoopsie, I don't want to use a highlighter, x minus 4 times 2x minus, not the other one, fg prime, this times that. And that's easy, right? That's just going to be x squared minus 7 times 1. If you simplify the numerator, and you're going to need to, if you simplify the numerator, you will get 2x squared minus 8x minus x squared plus 7 all over x minus 4 squared. And if you combine the like terms, let's see if you have any like terms. You have 2x squared and minus x squared. If I combine them, I'll get x squared minus 8x plus 7. And this is all over x minus 4 squared. Now we found the derivative, right? We found the derivative. Let's go ahead and use this to find some critical values. Now remember, because we did something like this on one of the videos, the critical values happen when this derivative is set equal to 0 or when this does not exist. So when you have a rational function, this can happen when on the 0 of the numerator. So what you want to find is what are the values that will make the numerator 0. And also you need to find the 0 of the denominator, because that's when the function will be undefined. That's where the derivative does not exist. So if you solve both of these, we may get a couple of critical values here, right? -7, -1. The two critical value that will make this derivative 0 is 7 and 1. Let's check these, this side. If you solve this for x, then you'll get x equals positive 4. Well, guess what? We got 3 critical values to plot, 1, 4, and 7, which divided our number line into how many sections? We got 1, 2, 3, 4 sections. So I'm sorry, it's going to be a lot of checking now. We have to check each of these intervals and see if the derivative comes out to be positive or negative in each of these intervals. So first, let's find f prime of 0. 0 is a number that's to the left of 1, so that will work. Plug in 0 into this function, okay? Plug in 0 into the f prime of x. That will be 0 minus 0 plus 7 over 0 minus 4 squared. Notice, because the denominator is always going to be positive because it's squared, the sign of this derivative just really depends on the numerator. And 7 over a positive number over positive, this will be a positive. So what we know is that to the left of 1, our f of x will be increasing. Now let's check this interval. This is the tedious part, but we need to show all the work. So plug in 2 into f prime of x, then you get 2 squared minus 8 times 2 plus 7 all over 2 minus 4 squared. Notice the denominator is always positive, because even if you do like 2 minus 4, you get a negative. Once you square anything, that turns into positive. So what's the numerator this time? I got 4 minus 16 plus 7. And it looks like that one is going to be a negative over positive. So when that comes out to be negative, you know this section will be decreasing. So continue this. You have to keep on going and check the sign right here and check this. Okay, now wait. You have to check the sign over there. So once you do all that, you will find, and that section is nothing more than just plugging in. So I know you'll be able to do that. So this will be increasing and this will be decreasing. So you got to write these intervals in interval notation, and I attached the solution all the way in the back. If you take a look, number 11D. Let's see, number 11D. The function is increasing on from -infinity to 1, 7 and infinity, and it will be decreasing from 1 to 4 and 4 to 7. So that's what you need to write down on your exam. But I'll be right back. I'll be back to take care of E through H very shortly, okay?